Hi, welcome everyone to SQLBits. My name is James Serra, and the session that I'm going to talk about today is Data Lakehouse, Data Mesh, and Data Fabric, what I call the alphabet soup of data architectures. So let's get to the presentation here. And first off, here is my email in case you want to contact me afterwards with any questions. And my blog is jamesserra.com. I have a lot of things I talk about today. I go into more detail on my blog, so you may want to check that out. Quickly about me, I've been in this industry quite a long time, 35 years. A lot of it focused on database and data warehousing. I was at Microsoft for 7 years, left briefly to go to EY, and now returned to Microsoft in Microsoft Consulting Services, now known as Industry Solutions Delivery. And a lot of my experience in the last 8 or 9 years has been in talking to customers about data architectures. And recently, the top that are buzzwords are data mesh and then also data fabric and data lakehouse. So hopefully you'll get a lot out of this through the presentation. You'll be able to talk to your customers or for your internal project and understand a lot better what all these terms mean. I will cover the data warehouse that's we've traditionally seen. I will talk then about the data lake so you get some understanding on what the benefits of data lake are, and then I'll go into modern data warehouse, and then the real meat we'll be talking about the data fabric, the data lakehouse, and the data mesh. I'll start off with a little bit of humor. I find a lot of people try to figure out what all these data buzzwords, data platform buzzwords mean, and sometimes it doesn't turn out well. So think of it as if I'm climbing this mountain of knowledge and I think I finally understand it all and I'm ready to soar to greater heights, and then this happens. So this is what I want to try to prevent by talking through this. And also want to mention these views in my deck are my own and not that of Microsoft. So I want to make sure that we clarify that. What is a data warehouse and why use one? This slide I've had around for probably 10 years now, and all of these still make sense. The thing that may have changed is I used to talk about copying data into a data warehouse, a relational database warehouse. Now with these new technologies, you can think of, you still need to copy the data, but maybe it's in a data lakehouse, or maybe it's within the domain of a data mesh that we'll dive into here. But the important thing is you need to copy the data. Otherwise, you have a lot of problems, such as I'm putting additional stress on the production system, and people are complaining. I was a DBA for many years and got very familiar with the kill command when somebody ran a query against some OLTP system that I had going. You also can protect against source system upgrades by copying the data. If the source system changes, maybe the ETL will fail, but the data warehouse will still be intact and people will still be able to get value out of that. And then other things like changing the field names over into something more meaningful. If you've been around a while like me and have dealt with some of these older database systems, in particular ERP systems, and they have naming conventions like T1112 that nobody knows what those mean. So you can rename those tables and those fields and make more sense for people to eventually get to self-service BI. So it's very important, no matter what solution we talk about, that you copy the data from the source system. When we look at data warehousing, there's two approaches that you can think of when you want to collect data. One is this top-down approach. The idea is I know what questions to ask, and this has been the traditional method for many years. I do lots of upfront work before I land the data inside of the solution. I'm creating a database and tables and fields and such. And so it's schema on write. I'm writing all that, I'm doing all this upfront work to make it easier to ingest, but there's a lot of work that's got to be done up front. As opposed to in a bottoms up approach, where I may not know the questions I want to ask. I want to do some data exploration, find out what I actually have. So I can land the data in this solution very quickly. So very little, if no upfront work needs to be done. And then if I find value to that data, I can model it later. So those are two ways to approach it. And the top-down approach has been typical for looking at historical trends. descriptive and diagnostic analytics, meaning finding out what happened and why did it happen. Where the bottom-up approach has traditionally been trying to do predictive and prescriptive analytics. Where are we going? What will happen? This is where AI and machine learning come into place. So it's important to understand these two approaches that we're trying to collapse into one when we think of some of the data architectures I'll talk about. Data warehousing traditionally has used a top-down approach. We gather all the requirements in there, understanding the strategy for the company. We then create the data warehouse. We do a lot of work, a lot of ETL development, and then we pump it into this data warehouse. Data lake has traditionally been a bottom-up approach, meaning I want to collect all this data that is really impossible to collect with some relational database in there, device IoT data, social media data, and I want to land that all in a data lake and then get value out of that. It could be running queries on that data, and it could be machine learning AI that I put on that, real-time analytics, and then it may be moving some of that data into a data warehouse, but I got some value right up front, right quickly with it. What we've seen is these two solutions work very well together. So most of the solutions up until recently have been, let's have a data lake and let's have a data warehouse, and we can do all of these four things on here. Historical value with the data and the predictive analytics with the data. For those that may not be familiar with a data lake, there's many reasons that you want to have a data lake. I've listed a bunch here, put in bold some of the more important ones, but all of these that if I had more time I would go through, but to point out a couple, one is think of the data lake as at the very least, it's offloading all that work, processing of the data that goes into a data warehouse. So traditionally, I have a data warehouse. Before the data lake arrived, I would have staging tables inside the data warehouse. I would have a maintenance window. I'd knock off all the users, and I would then start importing all this data into the data warehouse, and then I would clean it all. So I'm using a lot of compute, costly compute, and then when I'm done, hopefully, fingers crossed, no problems with the data loads and the cleaning, and then I let users back on. The problem with that is you now have a maintenance window, and if you want something 24/7, you're kind of out of luck in there. Also, if I wanted to use more compute and less expensive compute, I'm stuck with the compute in the relational database. So what you can use a data lake for is the staging area. So I land all the data in there, and then I clean it, and then I have a very short window where I just need to load that data in there. So instead of maybe having 8 hours of maintenance window, it's only a few minutes on there. So I can have that 24/7 data warehouse in there. I can also put more compute on that data. I can fire up a bunch of clusters, and they could be less expensive than data warehouse, and clean that data faster if I'm willing to pay more money on that. I also have the ability to have the schema on read, so I can land data in very quickly. And for those power users, especially data scientists who like data in a file format structure, they can go and make use of that data. They don't have to wait for IT to copy it and do all that work into a relational database. So those are some of the big reasons for a data lake house, but many more. And I would say every customer I talk to is using a data lake in some fashion, even if it's just for cleaning the data, but there's many other reasons you can use a data lake. So if we're using both a data lake and a data warehouse at a high level, this is what you can break down what each of those technologies does well. Data lake can be that for that staging and prep, as I just talked about. It could be also accessed by those data scientists or those power users. You also have the data warehouse that could be that serving layer and the security and compliance layer. For some things, for some reasons, as the security inside of a data lake is not as robust as the data warehouse, which has been around forever. And they have things like row level security and column level security and dynamic data masking. So a lot of times I see companies will use a data lake for staging and prep, but not allow the regular users on it. Instead, they go to a place where the data is nice and easy to understand, and they have something that they're used to, and they use the data warehouse in there. So the idea is try to have the best of both worlds in there. And there's a lot of other reasons that you can separate them out listed here. Those are the ones I wanted to point out, the major ones. I also want to point out data maturity stages that I see companies at. And stage one is, look, I have this data everywhere, and it's a real pain to collect it all and run reports off that. So a lot of companies are collecting all that data in stage two, and they're centralizing and putting it all in one place. They have this one version of truth. They have performance because all the data is located in one spot, and they're ready to get a lot of value out of that data. And most customers are still at this stage, but coming with a lot of customers is stage three and four, where we're getting this predictive analytics, where it's using machine learning on top of that. This is where I see a big tidal wave of machine learning coming in the future, because most companies being in stage two and they're using reporting off of it, but now they see the value they can get out of machine learning on there. So they'll be getting it to stage three. And then eventually to stage four, where the idea is I want to go through digital transformation, and I want to be a point where I'm collecting data no matter what the size or the speed or the type of the data. So that's where the transformation stage is, and this is where we can use some of these data architectures and the latest technology to get to that point that we can build something out that we don't have to worry that we won't be able to ingest certain types of data because we don't have the compute or the storage or the capabilities in there. So companies want to get to that stage four, and some of the technology they talk about are very hopeful that companies can get that stage four fairly easily. Okay, the modern data warehouse. This has been traditionally the way companies have doing data collection for the dozen or so years, and it's broken out in 5 stages here. And most people have these same 5 stages. They may call them differently, but the idea is, first I want to ingest this data in stage one, and I put in green here the products that would use for Microsoft, where stage one would be Azure Data Factory, ADF, to ingest the data, and to stage two, which is store the data in Azure Data Lake Store Gen 2. And I have in my data lake these multiple layers. And this gets into the data lake design and design of folders, which can be a long topic in itself. But the idea at a high level is I have a raw layer. So I dump the data as it is, and I do it quickly. So ELT on there, I'm not transforming anything in the way to have the less stress on the source systems. Then I need to transform the data. So step three is cleaning this data. And I can use technologies like Azure Data Factory data flows, or I can use Databricks, or I can use Synapse Serverless and land that clean data into the data lake again. And then I may want to go to a presentation layer where I'm combining that data or aggregating that data to make it easier for the end user to consume. And that end user could be in my little diagram below of a data scientist is he just needs that data in maybe even raw layer, and maybe power users can use it in the presentation layer if they're skilled enough with working with a file format structure in there. I also may want to create a sandbox for that data scientist so they have a copy of the data and they can do whatever they want with it. But in most cases, you can't go to an end user and say the data is sitting in the data lake, have at it with Spark SQL or something. More difficult for them. So you want to model the data, and that's where stage four comes in, where I'm copying the data into a format that is more conducive for the end user to use. So that could be a relational database in, say, the third normal form, and then I can even copy it into a star schema. And I can use a product like Synapse, which has these dedicated pools for this. And that brings me to step five, where I have that Power BI user who can now do self-service BI. They can go to a canvas and they can just drag fields off of that and create reports very easily without having to get IT involved. Now, some of the challenges that you may say of this is, well, I'm copying less data, so it's more complexity and more cost, even though storage is very cheap. Yeah, sure it is, but you're getting the benefit of having this data in a way that is very easy for others to use. So that's a big plus. And if it takes more work to get in that form, so be it. It's going to allow people to do things on their own. And so there are those trade-offs, but in many times it's worth it. Now, this is where we're getting to try to reduce these trade-offs with some of the newer data architecture technologies. What is a data fabric? Another big buzzword lately. I view, and this is my opinion, and not everybody will see it the same way. In fact, some people say a data fabric is the same thing as a modern data warehouse now. But what I do is, the way I think of it is a data fabric is adding additional features on top of that traditional modern data warehouse or that modern data warehouse, and features such as data access, data policies, having a metadata catalog and keeping track of the lineage of the data as it moves along, having master data management on it, have virtualization piece on there, being able to process in real time, have more data scientist tools, create APIs for accessing the data, and then maybe having the modern the solution in building blocks. So somebody can say, well, I like what you built in data fabric and you have this cool data ingestion piece, but I don't need the data fabric, but I can really use that data ingestion piece. So having those building blocks out and design that way so those pieces of what you build can be reused. The bottom line is the data fabric gets you that final stage I talked about, stage 4, is that you can source more data, secure it, and make it available by having this fabric that has the ability to go out and collect data no matter what the size, the speed, or the type. All right, a quick history lesson for you. We have this data lakehouse. Here's how this came about, the data lakehouse. We started out in the late 80s with a traditional relational data warehouse, Teradata and Netezza. For those of remember, Microsoft had a parallel data warehouse and renamed to Analytics Platform System that I first worked on at Microsoft. These were MPP solutions, massive parallel processing solution that can handle big data, and usually had this giant data warehouse, and then maybe they would copy some of this data into data marts, and that worked very well, and still works very well for a lot of customers. Then came the Delta Data Lake. This was the idea of we have a Cloudera, Hortonworks, and we have all this massive amounts of storage, and we use technologies like Hive and Spark and Storm and MapQuery, and we can just put all our data in there. We don't need a relational database, and this data lake is some land of unicorns and rainbows and leprechauns, and all the data will come out magically easily. Well, this failed miserably with a lot of customers that I dealt with in there. They realized you can't have all your users going against the data. Like you can't go and say to them, here's all the data in CSV files in a folder. Here's Hive SQL, have at it. It just didn't work. So what they found is they need a combination of having that big data technology in relational database combined with the data lake and use both together as I talked about. And this has worked very well and still works very well and will continue to work very well for quite a long time. However, a new concept that came around just a few years ago and promoted a lot by Databricks was this data lakehouse concept. The idea is let's go back to that time when we could put everything in a data lake. And don't worry, things have changed with the data lake. We've added some features to it that can make it a lot easier and a lot more performant to use than the problems we had before. So what is that technology that we're adding to a data lake? And that is Delta Lake. This is something that's been open sourced and a lot of products use now. And this is not additional storage. This is just additional software layer on top of a data lake. And it gives you additional features such as ACID transactions it supports, which could be very important. Time travel, versioning of the data as it comes in there. It allows you to do both streaming and batching, and it does it very performant. It also has schema enforcement, so I don't have to worry if somebody puts a file in there that's not proper in the schema. Instead of my jobs blowing up, it'll automatically not allow it in there. And then a big one, probably the biggest one, is the merge command. To do something like a merge command in a data lake is very difficult. You have or very slow because you have to load the whole table in there, change it all, and write it all back in there. Well, the Delta Lake makes that merge command go much, much faster. So very performant. And that's a big reason why customers use a Delta Lake, because they're coming to a point where they want to update data sitting in a data lake. So Delta Lake allows them to do that. Sounds great and dandy, but there are some concerns about it. But The use cases that it works very well for are solving these four problems. So you're keeping now, the problem is with a data lake and a data warehouse is keeping them consistent. Also, the data warehouse is almost always going to be older than the data in the data lake. It could be a few minutes, a few hours, a few days older in there. So you have to deal with that problem. You also have the issue where data on top of a, in a relational database is a lot harder for end users who are data scientists to use to build their ML models. A lot of the ML tools work much better against a file folder format. That is what a Delta Lake gives you in there. So those data scientists prefer to use the Delta Lake because you're not limited to the inflexibility of ML tools on top of a relational database. And then finally, even though cost is cheap, storage is cheap, it is reducing the number of copies from 2 to 1, or even more, or even more than 2 to 1, and so it could be a lot cheaper for a data lakehouse. And the data lakehouse, I'm defining it, and most people define it as one copy of the data in a data lake and almost always in a Delta Lake format. But there are concerns about just using a data lakehouse. So I listed a few of them here. One is the speed. You will never get the performance out of a Delta Lake that you would get in an MPP technology, such as Synapse or any other technology in the cloud that uses MPP technology, in that I can use that technology to run queries in millisecond time, or maybe a couple seconds at worst against billions of rows of data, which you'll never get that performance in Delta Lake. Now that could be fine. Maybe you don't care if queries take 5 or 6 seconds and you don't need them to run in milliseconds in there. And so that could be a concern or not. Security is usually a big one. There is no idea of a row level security or column level or dynamic masking inside of a Delta Lake. You have that in a data warehouse, in a relational database. They've been doing that for many years. So how are you going to replace that functionality in there? And we'll talk about alternatives to that. The complexity in Delta Lake, I'm dealing in a file folder based world. And that could be very challenging to people to use, especially if they're not IT people. And also the metadata is separate from the data or embedded within a file. So that could be challenging to search around for data, because in a relational database world, you start at the top with the metadata. So it's very easy to then define the data. With a Delta Lake, that metadata could be anywhere. And so it could be very challenging for people to explore that data and make sense of it and create queries. Concurrency can be a big problem in a Delta Lake. If you have a lot of people, hundreds or thousands of people trying to read the same file at the same time, that could be very challenging in a Delta Lake, but not so much in a relational database. And then the relational database is missing, the Delta Lake is missing some features like referential integrity is a big one. You'd have to do something like that in code, because there is no concept of putting that integrity within the files or folders in there like you can within a relational database. And then a lot of times you're locked into Spark if you're using a Delta Lake, and a lot of the tools only use Spark against the Delta Lake. And then finally, people are used to using a relational database. So you always have to keep that in mind when you're trying to build a solution: is who are my end users and what are they used to, and maybe it's worth it to try to get them to learn a whole new way of doing things. But you know people are resistant to change. You know there's going to be pushback. So you have to keep that in mind. And maybe that's reason enough not to go into a data lakehouse. Now, where this is starting to change is with Azure Synapse. That solution allows you to use T-SQL over data sitting in a Delta Lake, which is a big problem for a lot of people who love T-SQL. And if you go and say to them, well, now you have to use Spark SQL, which is close but not the same, you can have a lot of pushback on that. With Synapse, I can create a view on top of that data sitting in a Delta Lake and run queries and use regular T-SQL against that data. And the end user doesn't even realize it's against a file sitting in a Delta Lake. They think it's regular relational database. So that's one way Synapse reduces some of these concerns. And also if you're using Power BI allows you to ingest all this data into a tabular model in memory, so you can get very high performance, very high concurrency. It even has a feature like row-level security. So that could take away some of the concerns. Of course, you have to be using Power BI for that. But if you are, that makes using a data lakehouse more of a possibility. And then finally, when you get into things like serverless, it's a lot more cost savings than having this dedicated relational pool that can be quite expensive compared to a serverless option. So hopefully that makes you understand what the data lakehouse is. This is changing with Microsoft having in the future improvements to some of these concerns. They will continue to make queries against a data lakehouse much faster. They will add other features and just all I can say is stay tuned for what's coming down the pipe that could make the data lakehouse more of a viable option. Because now I would say most customers are not at the point where they can just keep everything in a Delta Lake. They still need that relational database. And at one time I said you'd always need a relational database, but with some of these new tools now, I'm starting to see the use cases where maybe you can get away with just a data lakehouse. And after some of the new features come out in some of the Microsoft products, you'll see more and more of those use cases become possible. All right, let's go to the data mesh. The biggest thing I'll say with the data mesh is the way it's to think of it at a very high level is all the solutions I talked about now have been centralizing the data. There's a caveat with virtualization, which I can get into, but it's mainly centralizing the data. With data mesh, the big thing is decentralizing the data, having it kept all within these domains or orgs within your company, and having them making the data available for others to use instead of copying all the data into a central location. And now you make all those domains, those orgs within your company, have ownership of the data instead of copying an IT and IT owning the data. Digging a little more into that is these four principles, which I'll talk about. However, I have to point out the data mesh is not a technology. It's a concept. It's a theory. And a lot of things sound great in theory. If you've seen the Minority Report movie, I just say, hey, in theory, you can just put all the data like that. So not to say data mesh is not a good idea, it is. And not to say it is not possible to build something in data mesh. It is, but there are very limited use cases right now, and the technology is not there yet to make this an easy solution. So I have to say, the one thing to keep in mind, if you're going to build a data mesh, it's going to take a lot longer to build something in a data mesh than it is into other things I've talked about, like a modern data warehouse or a data lakehouse in there. So you have to keep that in mind. And my point is that there are concerns, and if you are okay with those concerns, then go for a data mesh. But a lot of people are not aware of these concerns. The four principles that make up a data mesh are first, domain ownership. So like I said before, those domains, think of them as manufacturing and sales and a supplier as examples, they own the data. And they know the data best, so who best to own the data than them? Also, they are responsible for making the data as a product, meaning they have their own domain teams of technical people, and they create API code as one option to make others outside of the domain access the data and also the metadata so they can find out what exists. And they also have an infrastructure, all the hardware that they needed, whether it's in Azure or Google or Amazon. The idea is they control everything, and but they make it available to others to use outside of their domain. So that's data as a product. The third principle, which there are no tools that do this yet, is the idea of, well, if I have all these domains, I don't want them all going out and building their own solutions from scratch? Can I have some infrastructure as a platform where I just click a few buttons in essence and all the storage and compute and ETL code and access control are there for me, and I can start building my solution on top of that for my domain. So we're making it much easier to add additional domains in there. Because we don't have this yet, everybody's building it on their own. And hopefully one day we'll have it, but right now we don't. And then the last thing is federated computational governance. So the idea of that is I don't want all these domains going out and having their own idea of what data quality is and data security is. Let's have one group. This will have to be a centralized group or made up of people in all these domains that are going to define all these policies and rules that all the domains are going to follow. So we're making sure the data quality is standardized, that we have security on everything. We're following certain regulations. We have modeling done all the same. So you have to have this governance board that all the domains follow. So this is the idea of a data mesh, is to follow these four principles. Here's where the challenge comes in with people building data mesh. If I build a data mesh and now if I'm only using three of these principles, is it really a data mesh? Probably. If I'm doing only say the first two, is it a data mesh? Okay, maybe. But if I'm doing just one, domain ownership, is that a data mesh? I would say really not. And the challenge is people are calling everything a data mesh now. A lot of companies, third-party companies with products to sell, especially virtualization, to say, hey, we put virtualization on that, and each of those domains keep the data and own it, and the virtualization software will be the way to access all that data. Well, that's solving principle one, but it's not solving any of the other three on there. So I wouldn't call that a data mesh, but some people are using that term. So that's where it was getting very confusing. You have to understand these principles and understand how important these principles are if you're going to build a data mesh. So the data mesh, and if this diagram I list out the principles here, is you have these decentralized ownership of data products on there. We have this infrastructure as a platform that's centralized that can go out and quickly ramp up a domain. And then we have the federated governance on there that's centralized, that's making sure everybody's following those rules and policies that were created. And Zamak is the one that coined this data mesh term. A lot of these technologies have already existed for a while, but she put it all together in one package. And there's a nice Slack channel that has a lot of people on it that talk about data mesh. So I definitely want you to check that out if you're looking at building a data mesh. And so we have this mind shift. That's really what a data mesh is going from centralized ownership to decentralized ownership. It's going with a lot of ETL to a little ETL. It's using data as a product instead of data as a byproduct. Instead of having IT that's one giant engineering team to all these cross-functional domain teams that sit within each of these domains. And then finally going from a concept of a centralized data lake to an ecosystem of decentralized data products. So the four use cases that a data mesh really solves are lack of ownership. If I'm challenging my company with who owns the data and I'm having a lot of arguments about that, that in theory goes away because the domains own it now. And we don't have we have clarity now on who to talk to if there are concerns or questions about the data. If we have IT responsible for data quality, that could be a problem because they don't know the data as well as the domain does, at least in theory. And so data mesh solves that problem of improving the quality of the data. And then there's scaling. If I have all my data going to a centralized location, organizationally, people-wise, that could be hard to scale. So a better solution would be all the domains have their own people, and as we add more domains, we add more people, and it scales out. And so IT is not the bottleneck. And so that's a big advantage of the data mesh. And then finally, technical scaling. If I'm pulling all this data into a central location, that technology in there may not be able to keep up with all these requirements in there. Instead, if I have a distributed environment and each of those domains have their own technology and their own compute and storage, more domains, I just get more compute and storage, and I'm able to scale, where that could be very challenging in a centralized environment. Now, I have to say this is the one I probably disagree with more. We've had technical scaling for years, and we've kept up with it. Technology has not stopped. So people with data mesh make the argument, well, this is not working and projects are failing. Well, they're not failing in the technology, they're failing because the people and the processes. The technology is able to keep up. Microsoft has internal solutions that are dealing with many petabytes of data with a data lake and a relational database. They're able to handle that big data. So you have to be very, we'll just say, don't make that a big concern of yours, that the technology is not going to keep up. It is, and I think it will, no matter what data comes in there, because we've been doing it. So don't make that as the one reason in there. Think of other reasons why a data mesh listed here may help you out. Now, a data mesh, and this is where it gets a little fuzzy, is that within the data mesh, you have these domains. And think of the domains to start with is they're source aligned, is they get data from the data sources, and I may be a supplier, and I create an analytical platform from all these data sources, and all my suppliers and people use this are within the supply group are happy. But outside of the supply group, they may not understand a lot of terminology and the way data is laid out. So, and this is all brought through in the data mesh book that Zamek is going to publish soon, is that you may want to copy that data into a consumer aligned domain that makes it easier for the consumers to make sense of that data and to get value out of it. You also may want to combine the data for performance reasons. So if I have many domains and I need to combine this data all into one domain, say I want a profit and loss statement, it could be very slow performance-wise to try to have a query that's going to go against all these domains. So what I do is I copy that data and aggregate it into an aggregate domain. And I have that to consumers to use. And I'll even add, well, if you think about trying to get a customer 360, understanding all the various data about the customer to understand them better and maybe master the customer data, I probably want to do that first and then pass that along to these domains instead of all those domains trying to do it on their own. So this is great, but then it raises the question, well, then who owns the data and say this P&L aggregate? And wait a minute, you had talked about less ETL, but now you're adding ETL. And now you're actually centralizing the data into this aggregate. So this is where I have some trouble with the data mesh concept, and that they're kind of going against what I think the original idea was decentralization. Now you're adding some centralization to it. You have to because of performance reasons and because people may not understand the data. So this is also something to keep in mind. And the whole with customers getting into data mesh, the biggest challenge they have is how do I break out these domains? That's very challenging because even one org can have many different domains within it. And how do I make sure we're not duplicating effort? So domain architecture can be quite challenging, and that's why data mesh, just that alone could take a very long time to build. And so this brings up some of the concerns about the data mesh. One, there's no standard definition. You ask 10 people what a data mesh is, you'll probably get 11 answers. And that gets back to those 4 principles. People can argue it's only a data mesh if it's 4 or 3 of those. Other people can say, no, you just have one that's a data mesh. And then even within those principles, it could be hard to understand things. And it took me months to finally wrap my head around the data mesh and go, oh, okay, now I get it on there. So a lot of people are going to be in that phase where they don't quite get it yet. And even if they do get it, they may think of a data mesh differently than others. So how can we build data meshes if everybody disagrees on what a data mesh is? I would say the biggest problem with customers building a data mesh, and that's why I think a very small percentage of customers this applies to, is organizational change. Imagine you're a big company and you could have dozens of domains, and you're going to go to all those domains and say, okay, well, you're going to change the way you do things now. No more copying the data in IT. You're going to keep the data. You're going to clean and master it and create your analytical platform, and then you're going to write code to make it available for everybody else to use. And you're going to get people that go, wait a minute, I can barely keep this stuff running. Now I got to have all this extra responsibility on me. No, IT, you just copy the data and do what you want with it. I don't have any part of this. You're telling me I also have to build my own team out of my own budget? Why would I do all that? Well, it's for the greater good of the company. That's hard to get people to agree to. So this is where you have to have a culture where people are, yes, I see the greater good. Yes, we should do this. Yes, I'm willing to put more time and effort into it. Because all it takes is one domain to say, no, I'm not going to do that. Now you have a data mesh without that one domain. How do you solve that problem now? Big thing to keep in consideration. The performance issue, that's why we have these aggregate domains. Now you have to start doing that. You have trouble, especially nowadays, trouble finding good people to build solutions. Now you have to go get more people, which is going to be a very challenging for customers in there. You may have some domains that go, look, you're telling me you're going to build data meshes and take 2 years. I'm not going to wait that long. So forget it. So you don't get them on board. And have those, and you need those incentives like I mentioned in there. And then finally, I'll mention the last one on here is that some people, you have to have people that see the big picture of combining all this data. So if we've each of those domains going into their own silo and creating the data, and they're just thinking manufacturing, that's it, it may make it very difficult to take that data and combine it with other domains. So who is the one seeing the big picture? Who is the one that's going to create a data model that's going to put all this together? Because at some point you have to put a lot of this data together. So before that was IT. Okay, great. IT is going to get all the data. We'll build these models. We'll join it all. We'll figure it all out. Now that responsibility is taken away. Well, who's covering that responsibility? And that's where you could really struggle. You have to set up some kind of way of having a team that's going to create these aggregate domains and understand all the data and how it combines, which kind of goes against the data mesh principle of less work for IT. Now you're adding work into IT, or some other domain is going to be shoulder the burden of all this. So more of this is in my blog. There's a lot of other concerns I have with data mesh that I didn't publicize, but I don't want to get people to say, well, never use a data mesh. I want you to think about it, but know these concerns before you start diving into it. And so the keys for successful data mesh are you have to have current pain points. If everything's running fine, don't just go, well, this sounds great. It's a great leading edge thing. I want to go and build it. No, have those pain points that data mesh could solve. You have to have a company culture that's very open to change experience. You have to have experienced people who've done this before, and there's not many people who've done this before. Or you hire a consulting company like a Microsoft who's building these solutions out, as opposed to going on yourself. Be aware of those concerns. Don't just look at the buzzword. Don't just listen to vendors. I've seen some say, "Oh, we got data mesh in the box, so it's going to solve all your problems." Because it's not. There's no shortcuts to building a data mesh. It takes a lot of time in there. Don't go strictly by the book. As I said, maybe you're going to say, "Well, this is great. I'm aware of the concerns. We're going to follow 3 of those 4 principles, and that's fine. You're not having to try to solve all 4 of them." And then a very long runway, meaning it takes a long time to build a data mesh. This is not a 6 months or a year long project. This could be multiple years on here, especially if you have a lot of domains. So keep that in mind. This I got right from Zamek's book, and she said you need to score medium or higher in all these categories. So there's 8 categories, and so I would say right off the bat, most companies will look at this and go, no, we're not an early adopter. We don't have technology at our core. We're not open to a long-term commitment. We don't have executive support, and boom, right away, you're not a candidate for data mesh. So this will knock out most companies. But it's a good guideline to know, hey, we happen to be higher or medium in all these. Maybe a data mesh is for us. So this is probably the first place you should start to even think about if a data mesh is something you can build within your company. All right, data mesh on Azure. So not a lot I'm going to talk about this because it's changing within Microsoft. So right now we have a thing called Enterprise Scale Analytics and AI, where you can go and use some of the technologies that Microsoft's built to help deploy a data mesh solution. In particular, we have these enterprise scale landing zones that we have the templates for to use to build your enterprise scale analytics as that core foundation. And there's a lot of documentation on that, and it's a great thing to use even if you're not going to build a data mesh. Anything data centric can work well with this. And so any solution that's going to collect data, you could look at enterprise scale analytics. And this will be enhanced to focus more on the data mesh, but for right now, it applies to any type of solution you're building, which can be centralized. Here are some helpful links that Microsoft has out now, and PTN, he wrote a book on data mesh before it was called Data Mesh, so it's a great book to look at and understand better before you start. And then what I just talked about, the enterprise uh, scale analytics and AI, those links are right here, and you can go through them. And the GitHub has the deployment templates you can use to actually build all this out. So like I said, more to come on that, but there are some things you can look through now, and a few blogs too that I think you'll find interesting. And this slide is where I talk about my breakdown of different approaches for a data mesh. And for now, I just call them mesh 1, 2, and 3 type. Type 1, the easiest to build, but more away from the data mesh 4 principles, is that all the domains will use the same technology, and all the domains will will use a centralized data lake split up by folders or containers for each of the domains. So the data is centralized. The domains follow possibly 1 and 2 of the principles, and the exception, and this is where most companies, if not all companies, have an exception to the 4 principles, is we're centralizing the storage here, which can be very helpful for performance reasons. Instead of having all this data in different locations and having to try to query all that data and avoid having to go create these aggregate domains, hey, let's solve the problem by just centralizing it. And there's a lot of benefits to keeping that. And I think you'll see a lot of data mesh solutions that are centralizing the data, because you can in fact have domain ownership broken out by containers and put security on there, and yeah, they own the data, only they can access it. It's all centralized, but it's domain ownership in there through access controls on that data. Going to the next, type 2, is where domains use the same technology, but the storage is within each domain, which brings up the challenge of, like I said, combining all of that data together. And if you're using some technology like Synapse, you have to have these private links into each of the other domains. So that can be very challenging to set up. It could have very performance issues. I think this is where you'll see a lot of customers start to struggle, and some will be able to do this, especially as some more of the technology advances, but it's going to be challenging today. And then the third, mesh type 3, is, which I haven't seen anybody even come close to implementing, is each domain can use any technology you want, and they have their own storage that could be any technology. Where mesh type 2 was, you have separate technology, storage, but you're all using the same storage, like Azure Data Lake Storage Gen 2. Now you can say, I have a domain, I want to use Oracle, and I'm using data that's stored in S3 in Amazon, and then another domain is using SQL database or Synapse on Data Lake Storage Gen 2. Imagine the challenges of that. And to me, this would be the ultimate. Again, it sounds great in theory that all these domains are using whatever technology they want, and we are giving them help by having in the third principle of some platform that they can go and deploy it. And that platform would say, oh, all right, you want to be part of the data mesh, you want to create a domain, what technology you want to use? Uh, Amazon, Google, Azure, what storage you want to use, and it can go and deploy all that for you. Doesn't exist now. And then we can have governance and standards, principle number 4, on all that data. And we can govern it, whether it's in Synapse or whether it's in Redshift, we have the technology and the tools to govern it no matter what. Again, not there yet. So that's why I think type 3 may never come to fruition, because I just don't see companies having that nightmare of having all these different technologies from each of the domains. At some point, you're going to want to standardize them with very rare exceptions, and maybe those exceptions are where we use virtualization software to make it easier, but you're not going to have that full 100% data mesh concept when you start standardizing on technologies. A lot of times I get the question, well, what is the difference between a data fabric and a data mesh that you just explained? And hey, if I just use data virtualization on data fabric, don't I have myself a data mesh? Well, no, because one is usually when I see companies use data virtualization, is they centralizing all the data, and they may have offshoots where they're virtualizing the data a lot of times because they can't move it out of the country. But even if they said, well, we want that domain to own the data, and we'll just pull in that when we need it, you're having a centralized with some offshoots. It's not a full data mesh. They may also say those particular domains, okay, we have the data, you can use it, go ahead and use virtualization software, but we're not going to go and create APIs for you. So a lot of times when they have what they call a data mesh, it's not two, which I listed here, data as a product. And then they also may, in these cases, they still have a large engineering team because it's data centralized in there. So while some domains may have their own people, most of the people doing the work to get value out of this data is a central team. So the idea becomes, if I use virtualization software, I may have domain ownership, but I'm not doing any of the other principles: data as a product, infrastructure as a platform, and federated computational governance. So if you hear any third party go, hey, we sell virtualization software, you can easily create a data mesh, they're not. They're solving maybe one of those principles, and even that they may not. The domain may say, hey, just take a copy of your data and do what you want with it. So IT is once again owning the data, so the virtualization software is not helping anything with a data mesh, so don't call it a data mesh. Now, what I see is the future. My view, not Microsoft. And interesting, there was a blog recently that followed my same thought process. Is I think you'll see data mesh just become an extension of a centralized data solution. You're not going to have, in some very rare cases, all these domains that are going to, within a company, that are going to agree to follow some contract to make the data available. So most companies will say we can use data mesh in a few cases, but most of it's still going to be centralized. And for those companies that do say, well, we want to create a full-on data mesh, from my slide before, they're probably going to be in type 1 or type 2. They won't be in type 3. And you can argue that's not a true data mesh, but I can say, hey, look, if they're doing all those 4 principles and they're all using the same technology, then yeah, to me, that's a full-on data mesh. And then what I put here is, this is where I see percentage-wise, if you're doing a solution and you may create a data mesh, but you have domain ownership, and maybe even then not everybody has domain ownership. But if you do, you have one of the principles, but data as a product, I still see most companies, half of them are going to not do that. Nobody's done step three because the technology doesn't exist. If they're building on their own, there's very few and far between. And then even the computational governance, and they're federated, many companies have not designed policies that everybody's going to use. So taking it all together is where the arguments come in. Is it a data mesh if I'm only following some of these principles? The bottom line is ask what your users need in there. Do they need a data mesh? Will it be helpful? Will it solve these problems? And maybe the answer is, in a few cases, yes, but in a few cases, in most cases, we want to still centralize the data. Well, great, just have a mixture. There's nothing wrong with having a piece of your solution as data mesh and the other piece as a centralized data solution. So hopefully that gave you a good understanding of a data mesh, a data lakehouse, a data fabric, and a modern data warehouse. If you have any questions, feel free to reach out to me through the email right here. More of this is on my blog, and that may help you dig a little deeper in there. And if you still get lost and still confused, and many of us still are, feel free to help me, shoot me an email and help you out. So thanks everyone for your time, and have a great rest of SQLBits.